Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can 6 different video game cartridges be arranged on a shelf if 2 of them must be placed beside each other? Now this is similar to the previous video that talks about arranging 6 different cartridges on a shelf. But this time we have a restriction. Out of those 6, let's say a color blue and color yellow, if we're talking about colors, they must be placed beside each other anywhere they are placed. Okay, that would mean we are going to consider that as we look into the number of possibilities. Of course, we're going to use here the fundamental counting principle that talks about the product of all possible ways that we could do. So we have 1, 2, 3, 4, 5, and 6. Take note that last time we're able to use the this process. We have here 6, we have here 5, because as soon as we place a certain cartridge on the first placement on the shelf, on a second placement, 5 out of those 6 are only possible because we are not to repeat, or we cannot repeat the first cartridge that was placed in the first placement. We also have here times 4, 3, 2, and 1. Okay, we have a product of this 6 numbers according to the fundamental counting principle to solve for our answer. But this time, it's very clear that these 2, let's just say these 2 must be placed beside each other. That would mean, here's the hint, we can treat this as one object, because if we are going to move this, say for example on the first 2 placement, okay, just going to come up here, we have the first 2 placement. Then we have here 1, 2, 3, 4 other placements because we have only 6 placements on the shelf. These 2 will still be together. If we have them on the middle, or let's say this portion here, the second and third placement, they are still to be placed beside each other. So how do we solve this kind of problem, this kind of situation? We are going to treat them, this pair, as one. This would mean that they are counted as 1 and we only have 5 different placements instead of 6. You have this 1, 2, 3, 4, and this placement where 2 of them are strictly to be placed beside each other. This is also the same if this pair will be placed in the first or the second placement. We have 1, 2, 3, 4, 5, and you have here 1, 2, 3, 4, 5. So this is how it goes if we talk about our fundamental counting principle. And if you use this portion here, 1, 2, 3, 4, 5. Again, we are treating already the 2 that must be placed beside each other as one entity. So in the first placement, it could be the pair itself or other cartridge. We can place here 5 different cartridges. That includes the pair of cartridge. Okay, so 5 alone. Once you place here 1 cartridge or even the pair itself, we still have 4 more to be used for the second. Okay, and for the third we have 3, and then 2 and 1. So again, anywhere of this is a pair of those cartridges that must be strictly placed beside each other. So we simply need to multiply this to get the result for this situation. But there's another catch as to this. Okay, of course we are going to multiply this one here, 5 times 4 times 3 times 2 times 1. But for this specific pair, let's say again this is the blue colored cartridge and this is the yellow colored cartridge. These 2 could also be interchanged, right? We could also have another placement for the same structure Okay? For the same structure, let's just simply use colors here. Let's say the red cartridge is here, the green cartridge is here, the orange is here, and the purple is here, right? Just for this example alone. So if we have red, green, orange, and purple, we have the blue and yellow. But if we are going to interchange the cartridge on the specific pair, let's say yellow first before blue, these two arrangements are counted differently. What does this mean? Aside from 5 times 4 times 3 times 2 times 1, we are to multiply it with the number of times that they can be interchanged. That would mean we have this portion, blue before yellow. We could also have yellow and blue, which could also be true for all the rest of the arrangements here. Let's say blue and yellow, and whatever be the arrangements here. That's a different arrangement if we have the same 4, but we are interchanging the color for our pair. That would mean we are going to multiply this to 2 ways. Okay? Because there are 2 ways for us to interchange our, what you call this one, our pair. Okay? Now, I would like you to observe the next few processes I'm going to present, because this type of presentation or solution might not be true for all types of problems similar to this that have different restrictions. How can we establish a certain process? Here's the hint. Okay, there are 6 cartridges. There are strictly 2 of them must be placed beside each other. Hence, as mentioned earlier, there are only 5 placements, where one of which is the pair itself. But aside from that, the pair can also be interchanged. Here's the process here. We are going to use the idea of the factorial notation, where this first here can be written in a factorial notation. This can be written in this manner: 5 factorial. Okay? Because 5 times 4 times 3 times 2 times 1 can be written as 5 factorial. And this happens, as mentioned, because instead of 6 placements, there are now 5 placements because we counted the pair as 1. Then, we are going to multiply this to this number of arrangements we can do here. Since this can be, for the first arrangement, you can try here 2 ways. It's either blue and yellow. Once you try blue, we only have 1 option. Or once you try yellow, there's only 1 option as well. This is multiplied to the number of arrangements you can do for the pair. So you have 2 factorial. As mentioned here, 5 times 4 times 3 times 2 times 1 times 2, which is just the number of arrangements that we can do here. We can write it like this as well. This is what our 2 factorial is. And the first would be our 5 factorial. So if you have situations like this where there are restrictions for a pair or even a group of 3, that we will have that on the next video, we are going to count the remaining placements, take its factorial. This is possible because, of course, in this situation, there are no repetitions. As we try a specific cartridge in the first placement, it cannot reappear on the next few placements. So we have 5 factorial, as we only have 5 placements because we counted the pair as 1, times the number of elements on that group that you counted as 1, in this case, pair. So 5 factorial, the number of final placements, times your 2 factorial, there are 2 that strictly to be placed beside each other. The result of this is the result of this product. So we have 5 times 4 is 20, times 3 is 60, times 2, 120 times 1. So you have 120 possible ways for your arrangement in 5 placements where you counted the pair as 1. But then again, since the pair can also be rearranged themselves, times 2 factorial, which is just 2, so you will have 240 possible ways. This is 120 times 2, so you will have 240 ways. Okay, so again, this is what happens because there are no possible repetitions and that there is a restriction that 2 of them must be placed beside each other. And that is for Count It In. Talking about getting the luck of the draw For all in, subscribe now.